How do you solve for the Poiseuille equation?
You mean triangle p times pi to the d over 128 times length times Poiseuille?
What?
Well, it's simple. You have triangle p, that's your pressure difference, times pi, you know what pi is, times d, which is diameter. Alright, today we are solving for Poiseuille's equation. What is Poiseuille's equation? It is the volumetric flow rate. It is to solve for volumetric flow rate. So, Assist Britt, may you please proceed to read me my problem.
All right. What is the volume flow rate if the pressure difference is 50 millimeters of mercury for a blood vessel 20 centimeters long with a diameter of 4 centimeters and a viscosity of 200.
So viscosity equals 200. For viscosity, that is your Poiseuille or Poiseuille, however you want to say it, whatever floats your boat. But the symbol for that is a nice little squiggly N. That represents viscosity, Poiseuille. So, to solve for our volumetric flow rate...
Wait.
Oh, good stop there, Assist Britt. I just assume they know because we have brilliant people watching our show. But maybe you don't. Maybe you're interested to find out. So, to find out what this is your pressure difference. This is the symbol for pressure difference, triangle P. And to find, well, we have a pressure difference, triangle P, we have our length, we have a diameter, and we have a viscosity. But to find your volumetric flow rate, you need an equation. And this equation, my friends, is one of my favorites. Why? Because you can rhyme it out. So let me draw it out for you so you can see it so then I can teach you the rhyme and process. So it's triangle P, your pressure difference, which the units for it is dyne over centimeter squared times pi, we'll go over that in a minute, times diameter to the fourth, which is units centimeters to the fourth, over 128, where did that come from? Don't worry about it. Length in centimeters times your viscosity, which is represented by this symbol right here. And just to not cause any confusion with that being right over it, let me take that out for you.
All right, Poiseuille.
And I can put Poiseuille for you right there.
Poiseuille.
All right. Why is this one of my favorite equations? Very simple. You can remember it with a little rhyme. Triangle P times pi to the D. 128 times length times Poiseuille.
Just don't forget, it's
Ding.
over.
I'll do that one more time for you. Triangle P times pi to the D over 128 times length times Poiseuille. Simple. But don't forget that when it's to the D, it's to the fourth power. So keep that in mind. And pi, you might be asking, I know you're like, pi 3.14155926535 but you only need the 3.14. Don't worry about all that. So pi is 3.14. Boom. All right.
I have a question.
Yes.
What's the symbol for VFR?
VFR. Good. Brilliant question. So right here, boom. Q milliliters per second.
Perfect.
This is your symbol for volumetric flow rate. That's what we're solving for ultimately. I like that one.
Right
All
on
right.
the spot.
So now, what are we doing to solve this problem? This is a very generous problem. This one looks out for you. This one's got your back. When the world doesn't have your back, this problem does. Why? Because it's giving you everything you need. So all we have to do is plug all this in. So let's start with the triangle P, your pressure difference, and we put this all, let's move over here so we're not taking too much space, and then hopefully you can still see. Oh, you want to switch spots? Not bad. So triangle P, which is 50, and now it's going to be with dyne over centimeter squared, I'm dying, times 3.14 times our diameter of 4 centimeters to the fourth, don't forget, because you have to square that, over, or to the fourth power, over 128 times the length of 20 centimeters times Poiseuille of 200. So it's as simple as it looks. Now you just solve. Whip out your handy dandy calculator and start doing the math. Well, first you might want to do this one actually, because you got to get it to the fourth. So 4 times 4 times 4 times 4 equals 256. So now, just to be generous, we'll move everything down one. And remember your units, but since I'm just moving it down, I'm moving it down. 256 centimeters over 128 times 20 times 200. And now simply finish the problem. That is 50 times 3.14 times 256, which comes out to a ridiculous number of 40,192 over 128 times 20 times 200, which comes out to an even more ridiculous number of 512,000.
Perfect.
Yeah. And then you divide those two. Boom. Boom. And your volumetric flow rate equals 0.0785. But if you want to make it simple, your volumetric flow rate equals 0.08 QMLS equals, this is your answer. Guess what you just did? Guess what you just did?
Don't forget, when you write your answer down, put your units.
Never forget. Never forget. But you just solved for volumetric flow rate.
Bravo.